Hello and welcome grade 11s to the Electromagnetism task video. Let's not waste any time and start with the questions. Remember, you can see the diagrams and questions in the series guide called A Guide to Electromagnetism. Pause the video at any time if you want to copy something down. Question 1. This diagram shows two compasses and a bar magnet. Show the direction that each compass will point. Question 2. A current flows in a conductor from positive to negative. Use the correct rule to show the direction of the magnetic field formed around the compass that is underneath the conductor. Question 3. Show the direction of the magnetic field around the following conductor. Question 4. Label the north pole and south pole of this current-carrying solenoid. Question 5. A magnetic field is produced when current flows through this open coil of wire. Give 3 ways in which the magnetic field can be increased. All the questions so far were based on magnetic fields and the magnetic field that forms around a current-carrying conductor. Now let's look at questions on electromagnetic induction. Question 6. The magnet moves past the wire in this diagram. Which motion will produce the greatest voltmeter reading? Perpendicular, parallel, or no motion at all? Question 7. Explain the term EMF. Question 8. A coil of wire is connected to a sensitive galvanometer as shown in the diagram. 8.1. What is observed when the magnet is moved towards the coil? 8.2. Explain why this occurs. 8.3. Describe what happens when the speed of the magnet is increased. Question 9. Wire number 1 with length L forms a single loop and a bar magnet is dropped through. Wire number 2 with length 2L forms a 2-turn loop and the same magnet is dropped through. Compare the magnitude of the induced voltages in these two cases. Choose the correct answer. A. V1 is greater than V2. B. V1 is smaller than V2. C. V1 is equal to V2 and not equal to 0. D. V1 is equal to V2 and is equal to 0. Question 10. 10.1. A light aluminum ring is suspended from a long thread as shown in the diagram. When a strong magnet is moved away from it, the ring follows the magnet. Explain why. 10.2. What would happen if the magnet was moved towards the ring? Question 11. Define magnetic flux. Question 12. Choose the correct answer. In order to change the magnetic flux through the loop, what would you have to do? A. Drop the magnet. B. Move the magnet upwards. C. Move the magnet sideways. D. Only A and B. Or E. All of the above. Question 13. One circular turn of wire of radius equal to 0,25 meters and a constant perpendicular magnetic field of magnitude 4,9 Tesla. Find the magnetic flux. Question 14. Find the magnetic flux of a triangular coil with base equal to 7 centimeters and height of 9,5 centimeters. The magnetic field has a magnitude of 4,6 Tesla at an angle theta equal to 22 degrees from the normal. Question 15. A coil has 5,000 turns. What is the EMF induced in the coil when the magnetic flux cut in the coil changes by 8 times 10 to the power negative 4 Weber in 0,1 seconds? Question 16. A square loop, 15 centimeters per side, sits in a magnetic field of 0,75 Tesla into the page as you can see in the diagram. The field changes to 0,75 Tesla out of the page in 0,1 seconds. 16.1. Calculate the induced EMF in the loop. 16.2. Calculate the direction of the induced current in the loop. Thank you for joining us for this series. If you had any problems with these questions, please watch the other videos in the Electromagnetic series for more help or go to our website. Goodbye.